Okay, good morning. Welcome to
FamilyMath308a.
308a. So we talked about topology yesterday, and you asked to talk a little bit more about topology today. So that's fine. We're going to talk about something called the Cantor set.
Okay.
We're going to talk about something called the long line. It's like a line that you normally know, except it's longer.
How can it be longer than infinity?
Yeah. Interesting, right?
Mm-hmm.
But before we talk about either one of these two things, we have to spend just a little bit of time talking about infinity.
Okay.
But the good news is we'll spend less than an infinite amount of time talking about infinity. So, did you know that there's more than one kind of infinity?
Yeah, I think so. Yeah. That's the numerical infinity. Isn't it? You get to this one by counting.
Yeah. Do you remember what this one's called? You said, what did you just call it?
Numerical infinity?
Numerical?
It sounds right.
This one's called countable infinity.
You can actually count it.
Countable infinity.
And then
And the idea on countable infinity is these are things that you can put in order. I mean, I guess we could start with 1 instead of 0 if we're going to talk about putting them in order. So something could be the first one, the second one, the third one, the fourth one. And so lots of things have this property that they're countably infinite.
yeah.
Can you show me something besides the integers, 1, 2, 3, 4, that we can arrange
Well,
that's countably infinite?
how about the even integers?
Okay, there's a good example.
2.
Well, even positive integers.
Yeah. Well, this infinity should be twice as much as this infinity.
Why is that?
Because instead of 1, you're getting 2. Instead
Okay.
of 2, you're getting 4. Instead of 3, you're getting 6.
All right.
Instead of 4, you're getting 8.
Okay.
Instead of infinity, you should get 2 infinity.
Interesting.
But isn't 2 infinity infinity?
Aha!
Hmm.
And instead of talking about how large infinity is here, we're talking about how many numbers are in the list. We're trying to count the numbers that are in the list.
There's still infinitely many numbers in the list.
Yeah, but how many might you think? How many numbers in this list compared to this list might you think?
I would think half as many. Because, like, if you only made the list to 8, you have 1, 2, 3, 4, 5, 6, 7, 8, and 2, 4, 6, 8.
Yeah.
You have 8 here and 4 here.
But if you're going to infinity, they have the same amount.
Maybe. In order to say they have the same amount, we have to say something's the first one in the list, the second, the third, the fourth.
Yeah.
And how can we do that?
Well, we can correspond the numbers to the digits. I mean, the integers.
Okay. How can we, what's the correspondence here?
Well, this would be the first one, the second, the third, the fourth, all the way up.
Okay. What about when I get to the number 100? What number would that be on the list?
Well,
Up here, there should be 50 up here.
How come?
Because everything is half of what is here.
Interesting. So I can almost factor a 2 out of everything, and I get 1, 2, 3, 4. And I get a nice correspondence,
yeah.
just like up here, and that shows me that I have countably infinite, even
Integers.
integers. Okay. Now, can you give me one other list that also has countable?
Well, maybe 1/2, 1/3, 1 plus a half plus a third plus a fourth plus a fifth, all the way down.
Interesting. So you just want to look at the fractions that have a 1 in the numerator?
Yeah.
Okay. Now we're not going to add them. We're going to keep track of them separately. So we start with 1, then a half,
Fourth.
then a third, then a fourth, then a fifth.
This.
So the question is, how many fractions are there that have a 1 in the numerator and a positive integer in the denominator?
Well, wouldn't there be countably infinity of them?
Yeah, that's a very interesting list. What's the correspondence? How do I figure out what's the first term in my list down here, the second, the third, the fourth?
The numbers in this list are the reciprocals of the numbers in this list.
Very interesting.
So you have 1/1, 1 over 2, 1 over 3, 1 over 4, 1 over 5.
Wow, those are both great lists.
Yeah.
I like that. I like that a lot. Alright, but now I'm going to show you a bigger kind of infinity, okay?
Okay.
Alright.